The reflection transformation alters the sign of the y-coordinates, which is pivotal for grasping the equation of the new curve. This change significantly impacts the visual representation of the graph. Moreover, transformation T translates the graph by adding 3 to the x-coordinate and subtracting 1 from the y-coordinate. This manipulation shifts the curve's position within the graph. In this context, the solution requires an understanding of the order of operations for transformations, clearly outlining how to execute each step meticulously to arrive at the final equation. Reflection across the x-axis adjusts the equation from y equals x squared to y equals x caret 2, effectively demonstrating how the graph flips. This step is essential for visualizing the transformations at play. When applying translation, the graph shifts by adding or subtracting specific values from the x and y coordinates. This results in a new equation that accurately represents the transformed graph. The overall transformation sequence comprises reflection followed by translation, showcasing the dynamic alterations in the graph. Grasping this sequence enhances one's understanding of quadratic transformations. The initial step in this transformation process is translation, which has a substantial impact on the structure of the equation. A clear understanding of this shift is vital for visualizing changes in the function. Following translation, reflection becomes the focus of the transformation. This process involves changing the sign of the y-coordinate, which ultimately reorients the curve. The culmination of these transformations results in a new curve equation, reflecting the effects of both translation and reflection. This composite transformation illustrates how various modifications interact within the function. Recognizing how to differentiate between curves based on their vertical translation proves essential. This distinction is instrumental in effectively graphing and analyzing functions. The concept of vertical translation is emphasized through observing the movement of curves in relation to shifts in their constants. This insight demonstrates how vertical displacements manifest in mathematical graphs. Finally, the importance of vertical translations in algebra is further examined, particularly in how they influence the y-axis while keeping the x-axis constant. This principle is vital in understanding function transformations.